NCM Learning Center.
Good morning friends, in this video we are going to discuss about the economic load dispatch problems from power system analysis. In the part 1 videos, first we will discuss the concept of economic load dispatch without considering line losses and penalty factor. Second, we are going to solve the three types of problems from the previous year GATE examinations. The example 1 is, we have to find the economic load schedule. If the obtained load schedule is within the given limit, how to solve the problem. The example 2 is, if the obtained power schedule violate the given limit, how to solve the problem. We will discuss. In the example 3, if graphical representation of fuel cost versus power is given, how to solve. We will discuss. If you know the three types of problem, we can solve any type of questions from the economic load dispatch concepts without considering line losses and penalty factor. Okay. Finally, do it yourself. I will list three questions from the previous year GATE and ESE Engineering Series examinations questions. You have to solve these questions. Okay. We will discuss one by one. First, concepts. Let us consider the fuel cost function of plant 1 to 3 are F1, F2 and F3. Where P1, P2, P3 are the power generation of plant 1, 2 and 3 respectively. A1, A2, A3, B1, B2, B3, C1, C2 and C3 are constant. Total power demand P is equal to sum of all the power generation. P is equal to B1 plus B2 plus B3 up to Pn. If N is the number of power plant. For economic load dispatch, incremental fuel cost of the plant must be same. This is a very important point. What is incremental fuel cost? Here fuel cost is given, F1, F2, F3. The incremental fuel cost of the plant means rate of change of fuel cost with respect to the power generation. Do F1 by dou B1 for plant 1, do F2 by dou B2 for plant 2, do F3 by B3 for plant 3. All should be same for economic load dispatch. So lambda is the incremental fuel cost. Okay. Next, we are going to solve three types of problems one by one. Example 1. If obtained economic load is within the given limit, how to approach? This question from GATE 2022. Here, the given is incremental cost, lambda is given 8 rupees per megawatt. Then the total power demand is given, only 2 plant, so total power plant is given, so P1 plus P2 is equal to 550 megawatt. Objective is to find the optimal power generation of plant 1 and plant 2. Okay. We know that for optimal generation of plant 1 and 2, the incremental cost of the plant 1 and plant 2 must be same. Here, the fuel cost function is given. From that, we have to find the incremental fuel cost. So, differentiate this equation, fuel cost function equation with respect to P1, we will get the incremental fuel cost of the plant 1. If you differentiate, you will get this. Okay. Next, we have to find the incremental fuel cost of the plant 2. So, differentiate the fuel cost function of plant 2 with respect to power P2, we will get this. A is constant here. For economic load dispatch, the incremental fuel cost is same. Here, incremental cost of the power is given 8 rupees per megawatt. So, equate this. This incremental fuel cost is equal to 8. Simplifying this equation, we will get P1 is equal to 50 megawatt. Total power P1 plus P2 is equal to 550 megawatt. P1 is known. Substitute this values P1 in this equation, you will get P2 is equal to 300 megawatt. Here limit is for P1 minimum value is 0, maximum value equal to 300 megawatt. P2 value also minimum value is 0, maximum value 300 megawatt. Is within the limit. The obtained optimum power generation is within the given limit. Okay, so this is the optimal power generation of the plant 1 and 2. So this is the answer. Next, example 2. If obtained economic load violates the given limit, what we have to do? Let's take a problem. Here three power plant is given. Fuel cost function of the three plant are given. F1, F2, F3 are given. The generation limits of the plant P1, P2, P3 are also given. The total demand is given 1000 megawatt. We have to find the optimal schedule. We solve. Here given three power plant is given, total load is given. So P1 plus P2 plus P3 is 1000 megawatt. Okay. Let us take this equation as 1. We know that for optimal schedule, that means economic load dispatch, the incremental fuel cost of the plant 3 must be same. Incremental fuel cost means rate of change of fuel cost with respect to the power generation. Okay. First we have to find the incremental fuel cost for the plant 1, plant 2 and plant 3. Equal to all of them. We can find the optimum schedule. Okay. Differentiate the fuel cost function with respect to power generation P1. We will get this. This is the incremental fuel cost of the plant P1. Next, incremental fuel cost of the plant 2, P2. We will get this. Third, 3 by 2p3. Incremental fuel cost of the plant 3 we will get 2. Now equate the incremental fuel cost of the plant 1 and 2. We will get. Then equate the incremental fuel cost of the plant 2 and 3. We will get this. Simplify this equation. First one we will get this. Let's take this equation as 2 and simplify these unknown equations. We will get this. Equate. Let's take this equation as 3. Here P1, P2, P3 are the unknown parameters. We have to find, but 3 equations are there. So just to solve this equation, we can get the parameter P1, P2 and P3. The maximum value of P1, P2 is 500, so it is within the limit, but for P3, maximum value is 250, the uptime value is 276, minus the limit. So, fix P3 values maximum value 250 megawatt. Now, we know that total power demand is 1000 megawatt, so let us take P1 plus P2 is equal to 750. Because P1 plus P2 plus P3 is equal to 1000 megawatt. And P3 is fixed 250 megawatt. So from that we will get P1 plus P2 is equal to 750 megawatt. Let us take this equation as 4. Now we have to find the economic load of plant 1 and 2 only. No need to consider P3. Already we know that incremental fuel cost of the plant 1 and 2. Equate this, we will get this equation. Let us take this equation as 5. Now solve this equation 4 and 5. We will get P1 value is 346.67 megawatt, P2 is equal to 403.33 megawatt, and P3 is 50 megawatt. This is the optimum load of the plant. Okay. Next, example 3. If graphical representation of fuel cost versus power is given, how to approach? Let us take a problem. This question is from GATE 2024. Here, the incremental cost of two generators, generator A and generator B is given, and also the incremental cost of the plant to be 7400 per megawatt is given. We have to find the total power demand. If you know the cost characteristics equation of plant or incremental cost equation of the plant, easily we can find the economic load. But here graph is given. So we have to find the equations from the graph. From the graph, minimum load of generator A is given 0 megawatt and minimum load for generator B also 0 megawatt. Okay. So first our objective is to find the incremental cost equation from the graph. How to find? Here x-axis represents the power, y-axis represents the incremental cost. So for generator A, let us take 2 points from this graph. Let us take 2 points. We know the equations, 2 point equations. Substitute this point in this equation, we will get equation. Okay. So first point, let us take a first point, x1, y1. For generator A, x1, this is x1 y1 point. x1 is 100 megawatt, y1 is 10,000. This is one of the point. Next, another point. This is another point. x2, y2. x2 is equal to 150. At the same time, y2 value 11,000. Here, x is the P1, power of plant 1. Y is the IC1, incremental cost of plant 1. Incremental cost means rate of change of cost with respect to the power generation. Okay. The 2 point is known. From that, you can easily find the equations. You know the 2 point formula equations. Y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. Substitute here. Y means IC1, incremental cost 1. Y1 value 10,000. Y2 value 11,000. X1 value 100, x2 value 150. Substitute here. Simply this equation, we will get this equation. Incremental cost equations. Let us say this equation is 1. Next, find the incremental cost equation for generator B. Let us take 2 points. First point, this point. When x1 is 0, y1 is 6,000. Another point here. When x1 is 100, y1 is 10,000. The 2 points known. Here x means P2, power generation of plant 2. Y means incremental cost of plant 2, AC2. So IC2 means rate of change of cost with respect to power generation. Okay. Substitute this point in this equation. We will get equation. So here y1 means 6,000, y2 means 10,000, x1 means 0, x means 100. Simply this equation you will get incremental cost of plant 2 equations. Let us take this equation is 2. Here incremental cost value is given. For economic load dispatch, incremental cost value should be same. So IC1, IC2 is given 7,400 rupees per megawatt. Substitute these values in this equation 1 and 2, we will get P1 is equal to minus 2,500, P2 is equal to 35 megawatt. But from this given, limit is given for generator 1 power, minimum power 0 megawatt. But here value is negative. Here P1 minus the limit. So fix the value P1 is equal to 0 megawatt, P2 is equal to 35. So total power will be P1 plus P2 is equal to 35 megawatt. So answer is 35 megawatt. Okay, this is the answer. Next, do it yourself. I will set 3 questions. The first question from GATE question 15. The second question from Engineering Science Examinations 2013. Third question from GATE 2015 set 1. Pause these videos, solve these questions, comment your answers. Okay. If you have any doubts related to the discussion, kindly post your doubts in our WhatsApp group or in the comment box of this video. Definitely you can get the clarifications. Okay. Continuously watch our channel. Definitely you can get the good knowledge in the field. Okay. Good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.